Hello math students, today's video is lesson 6.1, radians versus degrees. Degrees are a unit of angle measure that we are very familiar with. We've used degrees to measure angles since we were very young. 1 degree is 1/360th of a full rotation, or in other words, there are 360 degrees in a circle. So this unit of measurement and its value originated from ancient mathematicians. There's not really any certain reason as to why they chose 360 degrees to be one full rotation. There are lots of theories. One theory is that the number 360 was chosen because the ancient Babylonian calendar had 360 days. Another theory is that just 360 is a number that's nice to break. Like you can break it into lots of factors. And there could be also lots of other reasons. So what we're going to do today is we're going to come up with another unit of angle measure that actually has some sort of relationship to the circle. So what I could do is I could take a piece of string and I could cut it so that it is the length of one radius of my circle. It doesn't matter how big my circle is. Just go and measure one radius. I can mark a starting point and measure how many radii it takes to go the full circumference. So I could do that distance, do it as many times as necessary. You're going to see that regardless of your circle, you're going to have 1, 2, 3, 4, 5, 6, plus a little bit for the number of radii around the circle. So I'm going to say that you get about 6. But really what this is saying is, what is the circumference of the circle? Well, the circumference is 2 pi times my radius, which means that there are 2 pi radii that go around the circle. If you put 2 pi into a calculator, you're going to see that it's about 6.28, which is what that distance is, about 1/4 of a radius. So we're going to come up with a unit of angle measure that's dealing with relating the arc length and the radius. So first off, arc length is simply the distance between 2 points on the circumference of a circle. So if I choose maybe a point here and a point here, my arc length is that distance. Well, if I want to know what that distance is, what I could do is I could create an angle that goes where the vertex is at the center of the circle. If I knew this angle, I could figure out, well, what percentage of the circle is that angle? So that would be theta divided by 360. And then just multiply that by my circumference. So my arc length is this. If I come back and look at this circle that we had right here, if I was to create an angle that went through 2 of these points that I used when I was measuring the circle, one thing that you'll notice is this arc length right here is the exact same as the radius. We're going to define this angle right here as being what is called 1 radian. So 1 radian is where the radius is equal to the arc length. That's all a radian is that angle. Well, not every angle that you have is going to be a whole number multiple of that radian. That's about 57 degrees. You have angles that are 30 degrees, 103 degrees. Like there's lots of other angles. So what we're going to do is we're going to define a radian as, so it's just another unit for measuring angles. But I'm going to say if I have an angle in radians, it is just your arc length divided by the radius. So if I have an angle that crosses through a circle, if I take the arc length of this arc that between the 2 points where the angle touches the circle, divided by the radius of the circle, that'll give me radians. All radians really are is how many times does it take the radius to go from point A to point B. Let's go ahead and look at some examples. This first example gives me a diagram. It gives me an angle with an arc length, and it says to tell the measure of angle theta in radians. So I'm going to go ahead and say, well, I'm just going to take arc length divided by radius. And then it says round to the nearest 10,000th. That's 4 decimal places because the number 10,000 has 4 zeros. So this is 2.7143. Or in other words, it takes the radius 1, 2, and about a quarter times to go between these 2 points right here. The next example, convert 78 degrees to radians. Well, I don't give you a circle, but we could create our own. I'm going to say 78 degrees is maybe about this angle right here. I'm going to choose a number for the radius. I don't care what it is. Maybe I'm going to do 10. So I'm going to start by finding the arc length, which we said was theta over 360 times 2 pi times the radius. So I'm just going to multiply this fraction. The top, when I go 78 times 2 times 10, gives me 1,560. Keep the pi in there. On bottom is 360. Well, I can divide both top and bottom by 10. And then 156 and 36, I'm going to try maybe, if I go 156 divided by 12, it gives me a 13. 36 divided by 12 is 3. So my arc length is 13 pi over 3. If I want to know how many radians that is, I'm going to take 13 pi over 3 and divide it by my radius, which is 10. Well, dividing by 10 is the same as multiplying by the reciprocal, which gives me 13 pi over 10 radians for my answer. It asks for a decimal rounded to the nearest 10,000th. Except for it's not over 10, it's over 30. And to the nearest 10,000th is going to be 1.3614. So that means that it takes about 1 1/3 radii to go from point A to point B. Well, this took a lot more work than it really needed to. Making our own circle, coming up with an arc length, like that was a lot of work. I would rather have just some sort of formula that I can plug an angle measure in and it will give me the angle in radians. So let's start with our arc length. Arc length, our formula was theta over 360 times, we had 2 pi times the radius. I'm going to go ahead and multiply this out. If I multiply the top of the fraction, it's just 2 pi times the radius times theta over 360. Well, I can reduce this fraction, divide top and bottom by 2. Leaves me with arc length equals pi r theta divided by 180. If I want to know how many radians this particular angle is, I'm going to take pi r theta over 180 divided by r, which is the same as multiplying by 1 over r. These r's right here are going to cancel out, leaving me with pi theta over 180. So I could say if I have x degrees, if I just multiply it by pi over 180, that'll tell me how many radians I have. What this is really saying is, if I create a circle, and I have, this is 180 degrees. If I want to know arc length is just half of the circle on this one. I'm just going to say it's 1/2 times 2 pi r, which is just pi r. If I want to know how many radians that is, I'm going to take pi r, divide that by r, which just leaves me with pi. So I can say right here that pi radians is equal to 180 degrees. So I'm going to put my units on here, say this is pi radians, except for I'm going to abbreviate it as rad. And then my units on the bottom I was going to put degrees. So this is no different than taking something from inches to feet or feet to inches. This is just my conversion factor. If I want to go the opposite direction, if I have x radians, and I want to know how many degrees that is, I'm just going to take and multiply this by 180 degrees over pi radians. And that'll give me how many degrees. Once again, this is my conversion factor. Main thing to know is whatever unit you want to end up in, make sure that's on the top of the fraction. It's always going to be a pi and a 180. 180 is the degrees, pi is the radians. If I want to end up in degrees, put 180 degrees on the top. If I want to end up in radians, put pi radians on the top. That way my units will cancel out. So the degrees on number 1 right here are going to cancel out. The radians right there are going to cancel out. So if I have 2 pi thirds radians and I want to convert it to degrees, I would start with my 2 pi thirds. Because I'm going from radians to degrees, I'm going to multiply this by 180 degrees over pi radians. The radians unit cancels out, and so when I multiply this, I can plug it in a calculator or work it out by hand. It's not that difficult. I get 120 degrees. If I have 135 degrees, if I want to write this as, we're converting it from degrees to radians. If I want to convert this from degrees to radians, I'm going to take 135 degrees. I'm going to multiply it by pi radians over 180 degrees. So all I'm doing is multiplying by 1 because pi radians equals 180 degrees. These units right here are going to cancel out, leaving me with 135 pi over 180. Well, I can divide top and bottom by 5. So on top I've got a 27 pi. On bottom I've got 36. So we can go a little bit further. 27 and 36 can both be divided by 9. That leaves me with 3 pi over 4 radians. The last thing I have is I have this protractor. If I want to take and convert every 10 degrees on here from degrees to radians, I could do that. So let's say I want to do 40 degrees. I can say, well, 40 degrees times pi over 180. And then it's just 40 pi over 180 radians. The degree unit cancels out. And then if I reduce this, top and bottom can both be divided by 20, which leaves me with 2 pi over 9 radians. I could do the same thing on all of them, which leaves me with these as my answers.